Now, still looking at calculations in chemistry. Like I said, that chemistry calculation is the easiest part of chemistry. Just get the key points, get the key formula, and then the answer is there for you. What volume of 0.20 mole per dmq of sodium hydroxide solution would yield 5.0 gram of sodium hydroxide on evaporation to dryness? Now, like I said, the easiest thing to do is to just, first of all, just list out those things that are given to you. Like now you're given C. C here is the molar conc, which is 0.20 mole per dmq. And then you also have small m. Small m is the mass of sodium hydroxide, which is 5 grams. Then you also have the big M, and the big M is 40 grams per mole. Now this question is an example of solubility, but you can still solve it by a very simple formula. Now C is 0.20 mole per dmq. You have M, you have big M, but you're looking for volume V. So you ask yourself, which formula is it that has to do with C and V? And if you are following this particular series, you understand that in other ones I have taught before, you remember that N is equal to CV. And if N is equal to CV, we also know that only N is equal to small m over big M. So with this information, I can still solve this. Since I have C, I have M over big M, I have V, okay? And only N is equal to M over big M. So this N here represents M over big M, and I have M over big M. So I can just go straight and just write M over big M, which is N, is equal to CV. So and I have C, and I'm looking for V. So with this formula I have derived, in case I've forgotten how to solve solubility, I can use it to solve without stress. So what will I do now? Remember how I got M over big M is from this formula that N is equal to this. And the one I'm actually using is this N is equal to CV, because I have C, I'm looking for V, but M over big M is something as N. So I use to form a new equation which I will use to solve it right now. So what will I do? My M is 5.0 gram. My big M is 40 grams per mole. So it's equal to, my C is 0.20 mole per dmq. And then times V, which is what I'm looking for. Remember that this V should be in dmq. So with this, I can simply cross multiply, and this will now give me 40 grams per mole times 0.20 mole per dmq times V dmq is equal to 5.0 grams times 1 would definitely give you 5.0 grams. So with this, I can multiply 40 grams per mole times 0.02 mole and see what it's going to give me. So I now have it that 8 times V dmq is equal to 5.0 grams. So only V dmq is equal to 5.0 grams divided by 8. The answer absolutely is 0.625 dmq. So that's the actual volume of this sodium hydroxide solution that will yield 5.0 gram on evaporation to dryness. Now this is the answer. So you can also convert it to CMQ in case. The CMQ, it will now give us 0.625 times 1000 CMQ. Remember that's one of the formula for solubility. The answer will now give you 625 CMQ. That's the volume of 0.20 mole per dmq of sodium hydroxide solution. It will going to yield 5.0 grams of sodium hydroxide on evaporation to dryness to give you 625 CMQ. So you see, the whole idea is Don't forget these two formula. N is equal to CV, N is equal to M over M. It will help you to solve most of the question that has to do with concentration, mass, molar mass, and so on. See this other SSC question. The mass of cm³ of a gas S at STP is 1.0 gram. What is the molar mass of S? And they gave us the molar volume of gas at 22.4 dm³. Like I said, there are magic formulas in chemistry. If you know it, even if you forget the other major formulas, through it you can wriggle yourself out of that problem and you solve it. If you go to part 1 and part 2 of this video, I was able to list out most of those fundamental formulas you must know as a chemist. Now, what is given to me is small m, 1.0 gram, the volume, 800 cm³, mvg, molar volume of gas is 22.4 dm³, and big M is what I'm looking for. I remember very well that whenever you're looking for M, you have volume given, that's volume in dm³, all over the standard, which is 22.4 dm³, times the big M. The big M. Now, with this formula, I can always come out of this problem. What do? Now, I already know my M is what? 1.0 gram is equal to, my volume in dm³ is 800 cm³, which if I convert it is going to give me 0.8 dm³, all over 22.4 dm³, times the big M. In case you're wondering how I got the 0.8, because it's cm³, I need to convert to dm³. That means I just said 800 over 1000, all in dm³. It will give you 0.8 dm³. Now, but this case, I'm looking for the molar mass. So what do? Simple. I don't need to waste too much energy going through a long process. I will just cross multiply it, so it will give me 0.8 dm³ times the big M is equal to 1.0 gram, then 2.4 dm³. And then how do I eliminate the divides all of them by 0.8 dm³, divide this side by 0.8 dm³. So yeah, I now get my big M. My big M is equal to 1.0 gram times 22.4 dm³ divided by 0.8. Let's see what that will give us. The answer is 21 gram per mole. That is the molar mass of that particular compound, denoted as X here, is 28 gram per mole. Let's do this another SSC question again. What volume of hydrogen at STP will be produced when 48 grams of magnesium react completely with dilute hydrochloric acid, according to the following equation? The magnesium plus hydrochloric acid will give magnesium chloride, hydrogen gas as the final product. Now, if you look at the reaction there, what important thing you must know is that this equation is given to you to check the number of moles. Now, what volume of hydrogen is 1 mole? So what was the magnesium? Also 1 mole. In other words, in solving this, it's also interesting to make certain chemistry statement, like we said, 1 mole of magnesium yields 1 mole of hydrogen gas, according to the equation. So that gives us the right to use the magic formula I've told you about that will give us the answer in a jiffy. Now, remember that in this case, we are giving small m as 48 gram, and then we are giving big M of magnesium as 24 gram, and we are also giving the molar volume of gas as 22.4 dm³, and we are actually looking for V, volume of the gas in dm³ of the hydrogen. So like I told you, there's a magic formula. So when we look at it, you know that small m is given to you. There's no need of wasting much time. You just write it. Small m is equals to volume given to you over the standard volume of gas, to 2.4 dmq, times the molar mass, which is actually the big M, okay? So let me now fix the value. So we have here 48 gram is equal to V dmq all over 22.4 dmq times the big M we know is actually 24 grams. So if I cross multiply this, it's going to give me V dmq times 24 gram is equal to 48 gram times 2.4 dmq. And you see, this is too far. Even when you're solving your what you call jam question or UTME questions or any CBT question, you need to be fast. And these formulas they are magic formulas that make things very easy for chemistry students. So you now have here, since I'm looking for volume in dmq, I will divide everything here by 24 gram and 24 grams, so I can cancel it out. I now have my volume in dmq. And with my calculator, which is your best friend in chemistry calculation, I have 48 times 22.4 divided by 24, and my answer is just looking at me, nothing else but 44.8 dmq. That's the answer to this simple chemistry question. You can see the timing with which I arrived with the answer. If you can just remember these magic formulas that I listed out in the part 1 and part 2 of this series, you will come out of most of these chemistry questions. And look at another interesting chemistry question. The volume of 0.25 mole per dmq of solution of potassium hydroxide that will use 6.5 gram of solid potassium hydroxide on evaporation is dash. And they gave us the molar mass as 39.0 gram. They gave us the RAM of potassium at 39.0, oxygen 16.0, and hydrogen 1.0. Now observe that they did not give us the molecular mass, but they gave us the atomic mass. So the first thing we are going to do is to find the relative molecular mass of potassium hydroxide. Potassium hydroxide, and that will be from what we have here. That will be potassium plus 1 oxygen plus 1 hydrogen, and potassium absolutely is 39, plus oxygen is 16, plus hydrogen is 1. And if you add it up, 16 plus 1 will give us 17, and 17 plus 39 will give us 56 grams. So we now have the relative molecular mass of potassium hydroxide. So now let's see the item, the info that is given to us. They gave us C. Remember, anytime you see mole per dmq, that is molar conc, which is 0.25 mole per dmq. And they also gave us small m, which is 6.5 gram. And we already know the big M from this equation, and the big M is 56 grams. What are we looking for here? We are looking for V in dmq. And I told you this magic formula, if you remember it anytime, any place, chemistry calculation becomes a child's play. Now don't forget that N is equal to what? CV. And also don't forget that the same N is equal to small m over big M. So from this equation now, I don't have N, but I have M and I have big M. So I can change this equation now to become small m over big M is equal to CV. Remember that if it's a CBT question, speed is needed. You don't need to waste too much time. You need to get these magic formulas into your brain. You can solve any chemistry, most chemistry question, not any, most chemistry question, because the other higher ones we'll look at later. So you have M over big M is equal to CV. So what's M? M is 6.5 gram. Big M is 56 gram. Is equal to C is 0.25 mole per dmq, and multiplying with V, and we know that we are actually looking for this V. So to make it faster and easier for me, I will first of all get the value of this. So 6.5 divided by 56 absolutely will give me 0.116. So I have here as 0.116 is equal to 0.25 mole per dmq times V dmq. Remember, why I put this unit is in case it's a theory question, you need to tell the examiner that you are actually a chemist by putting the unit. But if it's an OBJ question or CBT questions, you don't need to do that. Just very fast and get your answer. So with what I have here now, I can rearrange it and put it this way so that what I will now have is 0.25 mole per dmq times volume in dmq is equal to 0.116. So bring out the volume in dmq, I'll divide everything by 0.25, 0.25, simple. It cancels out, so I have only V here. So let me make use of this space for those of, so for clarity's sake, so I have only V, and I have it that V dmq is equal to 0.116 all over 0.25. And with my calculator, my answer will be smiling at me. 0.116 divided by 0.25, and absolutely the answer is 0.464. 0.464 dmq. That's the volume of 0.5 mole per dmq solution of potassium hydroxide that will yield 6.5 grams of solid potassium hydroxide on evaporation.